Today I will talk about the DeepSeeker, which is LLM assignment 3, and it is a RAG QA system for the DeepSeek papers. So here is an overview of my project. So in my project, my objective is to integrate DeepSeek papers as the external knowledge and enable the LLM to answer the DeepSeek related questions. So my source data is the DeepSeek papers in the PDF format, and I downloaded by using the Google Scholar. And as for the language model for the answer output, I used the GPT 3.5. And as for the database, I choose the Circulite. And finally, I deploy my whole system on the Hugging Face, and I choose the Streamlit as my front end. So the first part is about the data processing. So I just seek the DeepSeek papers on the Google Scholar and download the PDF format. And then I use some Python packages to extract the PDF to the raw text. And then I use several functions I wrote by myself to delete the duplicate spaces and clean the text and spill into the manageable chunks. Here I choose 500 as my chunk's max length. So here is the pipeline overview. So after the pre-processing our data, I will use data extraction to extract the features from our raw data and then embed it to our database. And I use the the cosine similarity to calculate the similarities and retrieval the information according to the query. And then I use the prompt construction and feed it into the LLMs to generate the final answer. After that, I have a very simple evaluation and then finally deploy my whole system on the cloud. So as for the model details, I use the embedding models, which is the Mini LM L6 version 2. And as for the language model, I use GPT 3.5 as my language model for output the answer. To access the performance of a RAG system, I implemented the evaluation script that simulates the real user interactions by running the set of responsive queries through the entire pipeline from the semantic retrieval to the LLM response generation. So for the sample query, the system measures the total time required to generate the response. The evaluation code records the key metrics such as the response time for each query and then calculates the average response time across all queries. And this quantitative assessment helps ensure that our system is responsive enough for the interactive use. And in our test, the average response time have remained within acceptable limits, demonstrating that the system can deliver prompt answers even when integrating multiple process steps. And in addition to the latency measurements, I also use the qualitative assessment that's made by reviewing the relevance and coherence of generated response. Because I only enhance the system on the DeepSeek papers, so it is very hard to find a public benchmarks or find a specific metrics to evaluate it on my system. So I only use the review by eyes and compare it to the original papers to evaluate my generated answer. And the retrieval context from our SQLite database combined with the LLM output consistently process the answer that both contextually rich and accurate. So this performance evaluation confirmed that my RAG pipeline encompassing the data extraction, the embed generation, the semantic retrieval, and the prompt construction and final response generation is robust and efficient. So then I can deploy my whole system on by combining a front end and then send it to the cloud platform. So here is a demonstration time. So here is my front end. I implemented by using the Streamlit. So here you can type some questions you wanted to ask about the DeepSeek. So for example, what is the author of DeepSeek version 2? And here we can get the answer, and it can be answered successfully. But without the RAG system, the LLM, the GPT 3.5 cannot answer this question. And we can change another problem, like what is the pipeline of DeepSeek version 2? And it can elaborate the whole pipeline about the DeepSeek version 2 by using some formula and some details in the paper. And also you can ask what is the main difference between DeepSeek version 2 and version 3. And here we can also find the answer here. That is, cannot be answered by only use the GPT 3.5. So in conclusion, I here build an RAG system by enhancing the DeepSeek papers in and feed into the RAG pipeline, and I calculate the cosine similarities to retrieve the relevant information with the query, and finally use the GPT 3.5 as my output to and as for the demonstration, we can see that the LLM now can successfully retrieve some useful data about the DeepSeek papers, and I deploy this whole system on the cloud. So thanks for your listening.